lecture series on GIS. So the present discussion is about intelligent structure. In the previous lecture, what we have seen is the topology, application of topology, where normally we are using this application of topology. Rather, this topological application, how it is evolved, it is through a set of programs already. It is there, like build topology, a program. The name of the program, it is doing it for the purpose of assessing the fault or the mistakes or the the common problems of exploring the future relations through topology is called as the intelligent topology. So it is intelligent. One is investigating about the data structure and data normality, data and its application with respect to adjacency, connectivity, containment. Everything it is that above normally it's a type of analysis, data analysis, and this data analysis is performing on its own of understanding that how this data is likely to be assessed by a set of programs called intelligent structure. Now let us see the intelligent structure, and it is used. This structure is used in topology for identifying or recognizing the information that build, that connect, that uses by means of chain, nodes, and vertices. Normally, you know that the data, when you digitize it, you'll be creating nodes, and then when you connect number of nodes, you'll get your vertices. And once if you start and then click end, you'll become that becomes chain. So this is there. This connects the relation between the future, both adjacency or connectivity or containment. And this gives a lot of application to us to understand whether our digitization is correct, whether it is completed or error is there. And to find finally that to reduce the error, it means that we are moving ahead of getting more quality. So that's what this intelligent structure plays a major role on understanding how that this topology has the ability to make functional connections. Yes, only that this intelligent structure tells us how it's linked. What is that right? What is that left? Everything. You look at a picture, and only this picture is going to be used for the entire discussion. And I will explain in detail about the future. The diagram here, illustration here, or a figure here. This is a polygon A, and this is polygon B, and this is polygon C. There are three polygons: green, violet, and brown. And the polygon A started by digitizing from here. And so started digitizing from here and moves here 2, moves here 3, moves here chain 4, moves here 5, moves here 6, moves here 7, moves here 8, moves here 9, moves here 10. So this is how this polygon is there. Chain 1, chain 2, chain 3, chain 4 is common between these two. Chain 7 is common between these two. And you look at this picture is going to help us how intelligent structure plays an important role in topology for understanding its application for various uses. Topology in the above set diagram is established by a special computer program. As I already said, intelligent structure, it is arithmetic, that special program. That program creates the link between the future, or it establishes the connections, then enter into the database. Additionally, it will add the informations. This special program is run after digitizing and editing. Mind it always, after digitization, after editing all these things, now we are going to find out what is the relation between where the mistakes exist, where it is hanging, that if you could not be able to connect via digitization error, what will happen? You cannot establish analytical power there. This topology helps us understanding by using a build topology concept. Simply you come and give a command build topology, it will automatically do that. The database has the ability to search for connections and make the data structure more meaningful and more finding out the relationship between each other. And this is how it is a chain 1, it is a left poly 0, right poly A. And in B, and in connect B, and in polygon P, this is connection A and B of chain A. On left side is nothing, and right side is polygon. That's what it is giving. and in chain 2 left poly is 0, right poly is A, and in chain 3 left poly is A, right poly is 0, and in chain 4 left poly is A and B. Similarly, it moves on. Consider the 3 polygons in the database in the figure. Polygon A has 4 chains. The polygon A you take, it has 4 chains. Chain 1, 2, 3 and 4. With the number 4 is the connection between A and B. So it is a common chain in both A and B. So polygon B has also 4 chains. You see you have your 4 chains here, but the chain 7 connects polygon B and polygon C. Polygon A also 4 chains, but only one chain is connecting and acting as a relation between these two polygons. Whereas this chain is connecting between this polygon and this polygon. Topologically, chain 4 has A to its left and polygon B to its right. You see, topologically, chain 4 has polygon A on left, polygon B on right. Chain has polygon B, chain 7 has polygon B on left, polygon C on right. So this is the normally sophisticated GIS also keeps a polygon database identity and chains. These topological characteristics are very useful for spatial analysis. It is easy to see. If you look at a diagram or a figure, it will be very easy for us to understand. But assume that hundreds of polygons, assume that hundreds of lines, if you want to establish a network, only the system can do. And with that, you will put a number of questions onto the system will no time will give answer to us for further analysis. It is easy to see how polygon A is connected to polygon B and polygon B to polygon C. Topology uses adjacent chains makes connection. Topology uses adjacent chain. This is the adjacent chain between A and B. This connection establishes, you see, how polygon A is connected by chain 4, how polygon B is connected by chain 7 for C. This is the relation, and this relation is established here, and this is called a database link. As long as there are connections, topology can build bridges across a coverage to link features. For example, polygon A is linked to polygon C. Polygon A is linked to polygon C. So you see you have connectivity like this, but you know what is the actual connections between this? It is not established. The connection is over here, the connection is over here, but the connection between this is not established. In figure, the figure shows the database link where the real work of topology occurs. The database list chain as the main record. You see you are using only the chain for the establishment of these database features. The path work like this. When you want to illustration, you see you are explaining chain. From here it is moving, from here it is moving, from here it is moving, and it is coming. That's why these two chains are connectivity. That's what it is represented here, how digitization follows and then the link establishes. This is how the link is established from chain 1 of A to chain 4 of A, chain 4 of A to B, where the chain is same, and chain 7 from B it is connected to C. This is how the database link from left poly to right poly is connected. Sophisticated GIS will have extraordinary data structure assessment, and that will help us to understand how the databases moves. It is not necessary to move as you have seen in the last by reading every row. No, it will straight away connect where it is established the networks. So this will helpful for further analysis in GIS. That is the ability of intelligent structure for any analysis in GIS. Thank you very much.